students, my name is Bernadette N. Cansaran, your teacher for today. So let's talk about ratio test. Ratio test is a test used to determine a given series if it is divergent or convergent, having these three. So our ratio test has a formula of limit of n approaches infinity, absolute value of a sub n plus 1 over a sub n is equal to L, which is, it is a limit. So our first condition is, if L is less than 1, then it is absolute convergence. So if our limit is less than 1, therefore it is convergence. And if our L is greater than 1, then it is divergence. And if our L is equal to 1, therefore it is inconclusive or need further tests. Since we know the three conditions, if it convergence, divergence, or inconclusive, let's have an example. Let's say, for example, So let's have an example. Summation of n is equal to 1 to infinity n over 4 raised to n. So let's have this problem. Let's see if diverge or converge. So next, we need to identify what is our a sub n. Our a sub n here is the n over 4 raised to n. And our a sub n plus 1 is equal to what? Let's just add 1. Let's just add 1 in n. So we have n plus 1 over 4 raised to n plus 1. Now, let's substitute the given formula. So we have limit of n approaches to infinity. We have our n plus 1 over 4 raised to n plus 1 divided by our a sub n, which is n divided by 4 raised to n. Again, we need to multiply the means and extremes. So we have 4 raised to n multiplied by n plus 1 over n multiplied by 4 raised to n plus 1. So we have So we have 4 raised to n multiplied by n plus 1 divided by n multiplied by 4 raised to n plus 1. We need to do is that we need to separate it all so that we can erase the given if there is. So we have 4 raised to n multiplied by n multiplied by n plus 1. In our denominator, we have n multiplied by 4n, 4 raised to n, and 4. We can cancel out having the same term. So cancel. We cannot cancel n plus 1 and n, or n and n, because it has a what do we call addition. So we have we only have n plus 1 over 4n. Now, let's compute for its limit. So, n plus 1 divided by 4n, we need to what? Divide all terms by n. So, we have n over n plus 1 over n over 4n over n. So, n divided by n is equal to 1, and limit of 1 over n is 0. So, we don't need to write it. 4n divided by n, we have 4. So, therefore, we have 1/4. 1/4, 1/4, is it less than 1? Yes. 1/4 is not greater than 1, and 1/4 is not equal to 1. Therefore, our L is 1/4. Therefore, it is what? It is convergence. 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 And that is how to find or identify if the given series is convergent or divergent. So let's have another example. Another example, we have the series or the summation of -1 raised to n over n squared plus 1, where n is equal to 1 to infinity. First, we need to find our a sub n, which is the original. So the original is -1 raised to n over n squared plus 1. And next, we need to find our a sub n plus 1. So our a sub n plus 1 is that -1 raised to n plus 1 divided by n plus 1 squared plus 1. Since we already find that a sub n and a sub n plus 1, let's substitute from the formula. So we have a limit of n approaches to infinity, absolute value of a sub n plus 1, which is -1 raised to n plus 1 divided by n plus 1 squared plus 1 over our a sub n, which is -1 squared raised to n over n squared plus 1, the absolute value. So we have means and extreme. So we have n squared plus 1 multiplied -1 raised to n plus 1. So first, we just need to separate it all so that we can cancel later on having the same term. So we have n squared plus 1 multiplied by -1 raised to n times -1 raised to 1. We don't need to write it. Next, we have to multiply n plus 1 squared plus 1 over -1 raised to n. So we have n plus 1 times -1 raised to n. Now, you can see having the same term. Yes, we have -1 raised to n. So we can cancel it out, cancel, then now we can have this. So n squared plus 1 times -1 over n plus 1 or n plus 1 plus 1. Or we can also distribute it. So let's erase it. We will do the FOIL method. So the FOIL method here is that first, outer, inner, and last. So we have n plus 1 times n plus 1. So first, so our FOIL method is first, n times n is n squared. Outer, n times 1 is n. Inner, positive 1 times n, we have n. Last, we have 1 times 1 is 1. So, n plus n is equal to, so we can erase it. We have 2n plus 1. Then, here we also have 1. So, plus 1 again, we have 2. In here, we can just, since it is multiplication, we need to distribute the negative 1. So, we have negative n squared. Negative 1 times 1 is negative 1 over n squared plus 2n plus 2. So, now let's just simplify. Let's divide all terms with n squared. So, divided n squared, n squared, n squared, n squared, and n squared. So, the limit of 1 over n squared is equal to 0. Same true with 2n over n squared and 2 over n squared. So, ang natitira na lang dito ay negative n squared over n squared is equal to negative 1. And n squared divided by n squared is equal to 1. Since we have negative 1 divided by 1 and we have absolute value of negative 1 over 1 is positive 1. So our limit is equal to 1 and 1 is in number 3 where is equal to 1, then it is inconclusive, which we need a further test. It is inconclusive. That's all. Thank you, students.